In the past 6 months, I've been low-key obsessed with tape technology. I've worked with reel-to-reel, cassette tape, microcassette, but one thing I haven't touched at all is VHS. Most people think of videocassettes as an outdated way to store movies. But movies contain sound, which means they're also an outdated way of storing sound. All of which raises the question, what happens if you try to use a VCR as an audio recorder? For this experiment, I'm going to be teaming up with Cameron, aka Venus Theory. He and I have been meaning to work together for ages, and this just seems like the perfect project to collaborate on. Right now, the plan is pretty open-ended. We're each going to get a hold of a VCR, do some test recordings, and see where that takes us. Maybe we'll make a sample library. Okay, so the machine I'm using today is made by Quasar, not a brand I particularly associate with quality. In fact, I'm just realizing now it doesn't even have stereo inputs and outputs. Nonetheless, let's hook it up. First, I'm going to plug the output into the input on my computer. Next, I'm going to hook up the input to a synthesizer, in this case a Moog Mavis. And finally, I'm hooking up the video output to a USB capture card that I just happen to have lying around. I'm doing this because even though this is an audio experiment, I still want to be able to see what the VCR is showing on the screen. The on-screen display is actually the only way to see the counter, which will let us know where we are in the tape. Speaking of which, here is today's recording medium, an old cassette that says "The Fish That Saved Pittsburgh" on it. I found this in a free box on my street, and true to its label, it does in fact contain an extremely grainy copy of this movie from 1979. Okay, I'm going to hit record. The first thing we want to see is if this even works at all. Apparently, a lot of VCRs won't even record if you're not providing them with a video signal. So right now I'm just going to play some random notes on the synth, and we can see what gets recorded. Okay, we don't have to watch this in real time. Time to rewind and see what, if anything, got picked up. Okay, I'm going to record the output of the VCR onto the computer. Okay, so it definitely works. Again, I don't think we're going to watch this in real time. Okay, now that we've got those recorded, I'm going to chop them up, label them, and turn them into a tiny, bare-bones, decent sampler library. Let's give it a spin. It actually sounds really cool. Let's add some reverb. It has a warm, very familiar sound to it. I have to send this to Cameron. Now that we've got our proof of concept out of the way, let's talk a little bit about how these things actually record, because it's fascinating. So an important thing to know about VHS is that the tape moves very, very slowly. Like, check out this footage. You can barely see the reels spinning. Now, as a general rule, the slower the tape speed, the crummier the recording quality. So to get around this, clever engineers designed VCRs to have this thing, a spinning drum which contains tape heads. Because the heads are spinning around very quickly, 1,800 rotations per minute, VCRs are able to achieve much better quality, almost as if the tape were running across the heads at a much higher speed. When VHS was first introduced in 1976, these spinning heads were only for video. Audio was recorded by a fixed head, just like a standard cassette recorder. This system is now referred to as linear audio. Because of the slow tape speed, the sound quality was awful, so in the mid-'80s, a new standard got introduced called hi-fi stereo.
But you're only hearing half the fun until you hear Zenith's hi-fi stereo VCR.
These new VCRs came with 4 spinning tape heads, 2 for video and 2 for audio. Each rotation of the drum corresponds to 1 frame of video, as well as the accompanying audio. And the signals for each frame are stored on the tape in diagonal chunks. But here's the thing, while it makes perfect sense to think of video as being made up of discrete frames, audio is continuous, which means that the VCR actually has to sort of reassemble those diagonal chunks of audio. To make matters more complicated, the different heads are located in different spots on the wheel, meaning that they represent different moments in time relative to the start of the frame. So a substantial amount of engineering was required to make all of this work. Of course, the sounds our friend Quasar here just produced were delightfully retro. Certainly not something anyone would describe as hi-fi. So what gives? Well, when the heads aren't aligned properly, or when they're dirty or broken, VCRs are designed to fall back on the old, dodgy linear audio system from the 70s. Another situation where that might happen is one where the manufacturer was just so cheap that they didn't bother to include the circuit necessary to decode hi-fi audio. Behold, the secret to lo-fi. Of course, I'm not complaining because these are exactly the sounds I was going for. But it is crazy that in 1999, a company would skimp on what was obviously a standard feature by that point. Let's try another experiment. I'm curious about how reliable the pitch is, so I've made a little sample set and I'm going to try to record it to the VCR twice. I'm deliberately running it at the slowest speed. I assume that the slow speed is most likely to produce that tape warble that I'm looking for. Now that that's recorded, I'm going to repeat the process. I'm going to record the exact same samples back to the tape again. And then I'm going to rewind, and I'm going to play back both recordings of those samples into the computer. Okay, so I've just recorded those same notes twice. So if the speed is reliable, those should line up like perfectly. Well, they almost line up. Not exact. I wonder what it would sound like if I played them both at the same time. I'm going to update my sample library with these new recordings, and we can try that out. Okay, I've now integrated those new samples. I put the first take on the left-hand side and the second take on the right-hand side so we can hear both at the same time. This is nice. Because it's actually two distinct recordings and because the two passes aren't quite in sync, you get this subtle chorus effect. Having worked with a ton of handheld tape recorders, I was surprised at how reliable the speed on this thing was. One reason for this is that when you record onto a VHS tape, along with the audio and video tracks, the VCR also writes a control track that contains a special signal marking the start of each frame. When a VCR plays the recording back, it listens for those signals. If it detects that it's falling behind, it speeds the motor up to adjust, or slows it down as needed. Let's get back to our experiment. So I can definitely hear the difference between the original and the VHS version of this sound. Here's the original, and here's the VHS. So quite different. It seems clear that some aspect of the frequencies are being changed when I'm recording to VHS. To see what's actually happening, I've just sent a 5-second burst of white noise to the VCR and then recorded it back. Okay, so this is the white noise we started with. As we can see, it contains pretty much all the frequencies in the hearable spectrum in pretty much equal proportions. And this is the white noise that came back from the VCR. It looks quite different. A lot of the bass is missing, and we can see there's a significant drop-off after 7,000 hertz. So part of what I described earlier as a warm, inviting sound is just the VCR lopping off some of the frequencies. A few days have passed. I love the way that initial synth patch sounded so much that I've repeated that sampling process over and over again with a bunch of different synthesizers. I used the Micro Freak. Of course, I used the Moog Mavis. And I even used the Volca keys. I ended up with 24 different presets. Meanwhile, in another studio, about 800 miles away, Cameron has been hard at work on his own gorgeous VHS samples, which he just sent me. He has his own video about this process, which I'll link to below. As you can see, we've put our minds and our sounds together. All told, there are 49 presets. A treasure trove that runs the gamut from 70s educational video music to FM modulated 80s synthwave, all the way through early 90s soundtrack work. These are all available for purchase on decentsamples.com, so if these seem like your kind of sounds, I do hope you'll check them out. If you enjoyed this video, it'd be great if you could hit like. And if you haven't subscribed yet, now is a great time. I've got a bunch of videos on the way. Okay, I think that's it. See you soon.